All right, welcome back, students. In this video, we're going to cover lesson 2-5. This is three-dimensional figures. So we've got two standards for this lesson. That's GR 4.4. I can find surface area of 3D figures. And GR 4.5, I can find volume of 3D objects. So 3D, three-dimensional, a little shorter than writing the full word there. So anyway, got a little vocabulary at the top. I meant to bring my little 3D things on my desk home, and I forgot to. So that's going to make this video a little more challenging, but that's okay. We'll do the best we can. So we're going to quickly talk about the vocabulary here and the formulas. If you guys want it, and let me know. Either send me a message in Focus or in the comments if you're listening. If you want me to go into these formulas and why, or give you the best why I can, let me know, because I know everybody learns different. I like to know why, but not everybody does. So for this video, I'm going to give you the words, and we'll just kind of brush across this. And the reason I say brush is because these formulas are on the EOC reference sheet. So you'll have these for the test. So memorization is not needed. But for this stuff, so as we talk about this, there are pieces of the puzzle that you're going to have to solve in order to set up the equation to do this. So that's where it's a little more tricky. So vocabulary on the left. So P is for perimeter. Of course, perimeter is, this is a three-dimensional shape, so we would go here, here, back side, this side, so all the way around. Height, so that's how tall it is. Like here, this is how tall this cylinder is. It sits on the circle. How tall this cone is, this is an imaginary line through that. You also have this cursive L, we'll talk about in a second. That's a different height, but your true height, or how tall it is, right there. We don't need any of that for the sphere. The sphere is a circle, so all you need is a radius. That's the nice thing about the sphere. So yeah, let's go over here. Yeah, so slant height. So a cone, circle is the base, but it looks like this is kind of like a triangle. Again, I wish I had my figure. But the slant height is going up the side of this thing. This is how tall it is. This is like if it was a pyramid, a building, this would be the side of it. This would be how tall it is. Hopefully that makes sense. All right, so big B here is the area of the base. So like for this regular pyramid, the base is the square. So to get the base area, it would be side times side, or side squared, because of the base area. This, for your base area, length times width. I say that because that's one of those things that it doesn't normally give you unless it's going to ask for one of these sides. Let's see. SA, surface area. So that would be what it would take to, if this was a box, and you were wrapping, say, a birthday or a Christmas present, that the surface area would be how much paper it would take to cover it. Or if you were going to paint it, so paint the whole thing, two bases, top and bottom, and then all the way around it, so the perimeter and then the height. Again, I just explained. But anyway, so surface area. And then volume, so surface area here, we find the area of the circle and then how tall it is, because the area here covers this area and it's shaded in because that's how tall it is. Now volume is how much it would take if, like, we fill it with water, or say this is an ice cream cone, how much ice cream would it take to fill it up if we filled it to just the line here? Or the sphere, how much air, or how much, if we were filling it full of water. Surface area, if we were to wrap it up, we're giving a basketball or somebody for Christmas, how much wrapping paper would it need? That would be surface area. How much air does it need? That would be volume. So, all right, moving on. Example 1 on the left. And I know how long this took in class, so if I skip around a little more than normal, I apologize. It was just this lesson's a little disconjointed, so it doesn't flow very smoothly for me. All right, so example 1. Determine whether each solid is a polyhedron. So no mention of polyhedron up here, but a polyhedron is going to be a shape, a 3D shape that has bases, faces, edges, and vertices. If it doesn't have all of these, then it is not a polyhedron. So skipping around, looking down here at this cylinder, it has a base, but this is not a face. This is because basically anything with a circle is not going to have a face for the most part. So our cylinder is not a polyhedron. All right, so up here, this guy is. The base, this is basically 2 pyramids with a square base on top of one another. So you have a square base. And we're gonna go around it. To name it, it's RUTS. And you could do that at any point or go in any direction. So we're only gonna name it once though. RUTS is the base for both of these guys because their bases are touching. Faces. So the faces would be if you're, sitting on your base and you're looking straight at me with your face, this would be your face. So your triangles. And they're triangular bases. Now, we're not going to name all of them because we don't have the room. I don't know if you're listening or watching and you have one of the other teachers at the school. I'm not sure what they're asking, what I'm asking. So I want one of them. I'm just going to give this one, but you could give this one or back here. You see there's 1, 2, 3, 4 triangles. Why? Because the square is the base. It has 4 sides. Every side has a face. So we're just going to name one of them. So TQU. We're just picking that one. All right, so edges. So your edges would be, and again, if I could show you, but like the edge of the table that I'm on, I know you can't see that, but this would be an edge. This would be an edge. This would be an edge. And then a vertice is, of course, the points. So you have one at the top, one at the bottom, one here, one here, one here, and one here. So we just would take the square, RUTS. I prefer RTR, Roll Tide, for you Gators and everything else listening. But RUTS and then these two, QV. Some of you guys are like, what is he talking about? So let's just kind of make it a little easier. So this guy wasn't a polyhedron. So example 1, check. One of these is not like the other. One of these is a polyhedron, one of these is not. Just to throw a little hint there, so this guy is laying on his side. The triangles on the front and the back, those are the bases. The faces are the rectangle. So, a little help with that. So, moving on. Example 3 at the bottom. So, find the surface area and volume of the cone. Round each measure to the nearest tenth if necessary. So those formulas were at the top. I'll write them. Let's just do this. We'll say, so at the top, surface area equals. So for a cone, that is base area. So we find the area of the circle here, plus, let's see, pi RL. So pi times the radius. Notice this is that radius of that circle that's the base. So plus pi r, and then the slant height. So remember I said it has a true height. That's this. That's how tall it is. And it's dotted because it's an imaginary line, but we need this. Now, if your eyes are good like some folks were today, you'll notice that we got a right angle here. So we have a side, we need a side. So we have a right triangle. And if we need a side with a right triangle, we can use the Pythagorean theorem. So a squared plus b squared equals c squared. A couple of things I always like to mention. The C is the long side. The long side is always directly across from that 90-degree angle. Always, 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 always. So if you're looking for the long side, you're going to be adding. If you have the long side and you want one of these, you're going to be subtracting. Some of that you guys will remember from your previous math. Some of you guys won't, and that's okay. So a squared, and again, a and b don't matter. C is the only one that really matters because, you know, say 8 plus 15 is the same as 15 plus 8. Even if it's squared, it's the same thing. So 8 squared plus 15 squared equals c squared. That's what we're looking for. That's the slant height. That's the cursive L. It was up at the top. Let me redo this. This is terrible. All right, cursive L. That's what the c squared is going to be. We're looking for that side. All right, so 8 squared is 64. 15 squared is 225. All right, so I add these two together. 64 plus 225 is 289. So that gives me this side squared. Well, I want this side, not this side squared, so we're going to take the square root of both of these. So the square root of c squared is c. The square root of 189, and I'm going to use my calculator, and I hope you have yours with you. Square root of 289 is 17. So c, or your L over here, is 17. We need that. Well, sorry, I left it off the formula. You guys are like, what the heck's he talking about? This is what we were looking for. So now we can start plugging in numbers. So we have our L, that's 17. I'm going to put it in parentheses because the R, remember that's the radius, that's 15. Pi, I'm going backwards. All right, now we need to find the base area so I can plug this in. So the base area for a circle, and this is also on the reference sheet, but base area for a circle is pi r squared. We have an r, so we can do this. So it's pi times 15 squared. Well, 15 squared is 225. I'm showing you like this because there are some Alex problems where they'll ask you, or actually there may be some in the McGraw-Hill stuff too, that'll ask you to answer in terms of pi. So if they ask for that, this would be where we stop, but we're not doing that. We're moving forward. So we're going to multiply this out. Now, of course, I didn't bring the calculator from school, so I'm using my phone, so I'm going to be in trouble. All right, so 225 times, looking for pi, Lord, there it is, pi. All right, so let me stop here for just a second. So in this class, all year long, pi means that button. Unless it says, and there will be, Alex will say a couple of times, use pi equals 3.14. Unless it says you hit that button, because I don't know how far that button goes, but it goes a lot farther than our brains go. So we use that. Okay, cool. Now, so let's solve for our base area. So we get 706.858. We're going to round that up to 706.9. So the base area for our cone is 706.9. So now I can plug that in here. So base area, 706.9 plus pi times the radius times the slant height. So times 15 times 17. I got too close there. Let me just do this. So let's do the math here real quick. So again, pi times 15 times 17. Right here. 801.1. Forget the rest of that stuff. So the surface area for this guy is going to be 706.9 plus 801.1 because that's the two sides of this equation. So I'm going to take this down here. So surface area equals, so let's just, so you guys see it live and right here. This might even be something I can do in class, but 801.1. So we're adding them together. You get 1508. So 1508 is, and this is square inches. Area is always squared. Volume is always cubed. All right, so now the volume, real quick. You're like, man, we're already out of space. This is pretty easy. So the volume for the cone, I did this all day. I forgot the 1/3. So 1/3 times the base area times the height, so that dotted line. Now, we could, instead of going through all these extra steps, we could rewrite this formula. I'm going to rewrite it over here before we do the equation, but because I know the base area for square, the base area for the circle is pi r squared, so you could rewrite this formula, and it's actually written in the, I think it's on the reference sheet both ways. So it'd be 1/3 pi radius squared times the height. I replaced b with its formula. So if that's easier for you guys, let's do it that way. But for now, we've already got the base area. So the volume equals 1/3, 706.9 from up here, times the height. The height is at 8 inches. So what I do, because it's a third, I'm going to multiply these two, and then I'm going to divide it by 3 because they want a third of that. It's easier than saying 1 divided by 3 and then multiplying that by 706.9 times 8. So they want a third of that. Divide it by 3. So it'll be 1885.1. We're going to round that up. So the volume for this guy, 1885.1. And this is cubic inches because volume is cubed. All right, over here, this works a little different. But actually much easier. So volume for this guy, and you guys do the math, but I'm going to write it at least. So volume for this guy is base area times height, or volume is length times width times height. So you're like, well, which is which? So this is sitting on its base. Its base are these two rectangles. So this is the length. That's how long it is. This is the width. That's how wide it is. This is the height. That's how tall it is. So to get the volume, you just multiply these three numbers. I'll let you do that. And I expect when you guys turn this in, you don't just leave it blank in this. You actually are trying to do the work. Surface area is 2 times the base area, which is length times width, plus, back it up. Perimeter times the height. So this was your height. The only thing you guys are going to find, so perimeter, because this is a rectangle, length plus width plus length plus width. So this plus this. So because this is 5.2, this guy over here is 5.2. It's dotted because that's the back side of that figure. So you can't see that. You just see a solid little prism. And then if this is 10 back here, that's 10. And again, it's 6 inches tall. So work that out, please, and thank you. So this video is going to be kind of quick because these examples, and God bless the ladies that help us do the notes for us. They dissect the book and do a lot of cool things. And so what happened here, I think, Module 2, we're going through these basic shapes. You know, we see the rectangles, you see the triangles, just, nothing crazy. Nothing that looks like this, okay? Well, we're going to go over this stuff again in Module 11, but you're going to look at stuff like this. And this kind of, to me, looks like Spaceship Earth. So there's your bonus points for this video. If you send me a message in Focus and tell me that you heard me talk about Spaceship Earth in video for lesson 2-5, then I'll give you bonus points. So anyway, this thing looks like Spaceship Earth. It's triangles that are in a sphere, and it says it's a geodesic sphere. I had to Google that, and it showed me a picture of that, and I was like, well, that's cool. I saw that picture, but I still don't really know what it is. So we're going to call it Spaceship Earth. Anyway, they're wanting to know, so they give us the diameter. Of course, we need the radius, so this is an opportunity to talk about it. The diameter is, so the radius is half of the diameter. So when it gives us this 12-foot diameter, the radius in this case would be 6, half of 12. I just want to point that out because some folks forget. Let's see. Stand by just a second. Okay, so one of the things so this is telling you the weight of Spaceship Earth and how many lights, and it's covered by how many these crystal triangles, like I said. So they're asking you how many lights are contained on the surface within the area of a. So I actually didn't look at the whole thing, but this gets into weight. You're talking about density, and density is in module 11. So we're going to skip this only because, I mean, I'd love to introduce it early, but the problem is it's not on the test, and I don't want to overdo it with stuff that we're not going to be tested on yet. So we're going to skip this one, and then this one here. So notice this pool is not like an above ground pool it's the same all the way around. It's a lot of different stuff. So this is technically like two different figures. Like you've got a square here, and then over here this is so either way, it's two different shapes. Two different shapes together are called a cross section, and that is also in module 11. So again, I don't want to. You end up finding the volume for each of those, but we're not. And it says here, yeah, cross sectional. So we're gonna leave those two alone. And so I'm gonna apologize to my fellow teachers because I can't really see. There's something in my brain that's not working with this guy. So I attempted to use AI, but AI is trying to work this without the base area, and that's why I'm saying maybe I'm looking at it wrong. So we're going to skip this one, but we're going to do this guy because it's the other shape that's covered up there. So actually, hold on. Did we? Yeah, actually, yeah. So flip my notes over here. So this is it's a pyramid on top of the Washington Monument. So the base, it's a square base. So square base. We know that a square has all four sides are congruent. So it says that the side measures 34.5 feet. So 34.5, that's each side. So 34.5, 34.5, 34.5, 34.5, because it's a square. Okay. So for a pyramid, so the surface area is going to equal one base. So it has one square base that it sits on. Plus, we have to know how much to cover it, we have to go all the way around it. So the perimeter times the height. And the height is what we're going to be after. They give us the surface area. They want the height. So we're going to put this stuff in, and just like we find X, we're going to find the height. So I'm going to go ahead and find the base area so we can just plug it in. So the base area for a square is side squared because it's side times side. So 34.5 squared means the base area is, hold on, calculator please. All right, so 34.5 squared. So 1190.25. I think I ended up just dropping the end because it was 0.25, so it rounds up to 3. I wrote it down on the board as 0.6, so we're just gonna say it's 1190. So it's approximately. So it's approximately. That's what we're gonna say. All right. Now, perimeter. So perimeter for a square, because everything's the same, is either 4 times the side or just this plus this plus this plus, 34 and a half plus 34 and a half plus 34 and a half plus 34 and a half. Much easier to multiply. So 4 times 34.5. 4 times 34.5. So gives the perimeter 138. So you need these numbers because we're going to be looking for H. So we'll go down here. So surface area 21,821.25. So 21,821.25 equals perimeter base area. So base area is 1190. Just screwed something up. Hold on. The 1/3. What was that? Wait a minute. What? Hold on. Back up. What did I do? Oh, that's the volume is 1/3. But I have been telling you guys wrong all day. I was saying this because it's a square, but I put the formula wrong. I just realized. So I have to tell you guys tomorrow, or make sure we look at the right formula when we do it, when we practice we do the review tomorrow. So pyramid. So yeah, for you guys that were actually looking at the notes and not just believing me, that's why I tell y'all don't trust me. It's 1/2 of the perimeter times the slant height. That can't be right because it wants the height, not the slant height. And hang on a minute. See, that was what was squirrely with this thing. All right, hold on a minute. All right, well, let's think about our slant height. And that gives me a chance. So look down here. So the summary. Pythagorean theorem can be used to find. Sorry if you hear my daughter laughing in the background. I don't know if you can hear that or not. That's pretty loud. We can used it to find the slant height. So, no, we don't have. Hold on. Let me see. Back up here. The volume. Oh, God, I've been totally screwing this thing up all day. So this is much easier. Good Lord. Okay. All right. Back it up. No wonder I kept going back to volume. Good grief, man. So, all this stuff is still true because the base is still a square. And so, but we're talking about volume instead of surface area. My bad. I don't have the notes from class, and it's been a long afternoon already. So, the volume for the pyramid is 1/3. Yeah, we did do this right. That's right. Okay, times the base area. We don't need the perimeter. So, but you guys see how to do it. Times the height. So we don't have the height, but we do have the base area, and we do have the volume. What I did do is forget it was volume and forgot the 1/3. That's what I kept doing all day, but at least I was doing volume. So this is now this. So we have the volume. So volume is 21,821.25 equals 1/3 base area times height. Height's what we're looking for. So first thing I'm going to do is get rid of this fraction. How am I going to get rid of it? I'm going to multiply both sides of my equation by 3. So over here, 3 times 1/3 becomes 1. And 1 is understood, so it's gone. Over here, 3 times 21,821.25, and I'm going to use the calculator because I've already proven I'm not very trustworthy, this afternoon. My math is not mathing today. 821.25 times 3, because we had to do that to both sides. So 65 for 63.75 equals 1190 times the height, because we got rid of the fraction. So this is where we are now. Now all we got to do is get rid of the 1190. It's multiplied by the height being what we want. So we're going to multiply it by both sides. So the height is going to equal. So there was our 65,000. It's already in the calculator. Woo! Divide it by 1190 right here equals 55.0. It said to the nearest tenth. The nearest tenth would be 0. So the answer is 55, and that is feet. So the height of this pyramid is 55 feet. Sorry for the wild goose chase down the wrong question. But I do like the opportunity to teach you guys something, and you got at least another chance to see the perimeter. All right. Number 2 at the bottom, how can you apply the properties of three-dimensional figures to solve real-world problems? One thing we talked about in class, I'm not going to write it on here, but a lot of engineers will take a three-dimensional model of something, whether it's a building or a parking lot or whatever, and it may be scaled, 5,000 to 1, meaning their little model is a 5,000th of the size of the real thing. So they can design it however, and then see how it's going to look, and then there you go. And goes back to module 1, the ratios. So you would figure out your dimensions or your whatever for that, and then multiply it by the ratio. So is it for now. I will do a video. Let me think. I'll talk to the other teachers, see how they feel about me posting one before the test, because I don't want you folks still in the video, copying the notes and not doing the work. That's not what this is for. Anyway, sorry, enough of my sermon. If you guys have any questions, let me know. And until then, have a good night.